Hey everyone, in this video I want to show you how you can store data with PartyKit. So PartyKit servers restart under some conditions. For example, if your server hibernates, after 10 seconds you could set it up that your server goes to sleep. You might want to do that to save money so you're not getting billed when the server is not being used. At some point the server will need to wake up, right? Some activity will happen, and at that point you're going to want to recover state, right? So you do want to have some storage, something in storage that you can recover when the server wakes up. Another example of this is rebooting. Maybe the server that you're on, actually there's a fire, I don't know, and they have to move your code to a different server. So you want to be able to survive the reboot. You don't want to lose your state. You need to recover from storage. Of course, errors, server coding problem. I don't know. Maybe you didn't have enough caffeine when you wrote the code and you messed up. So you want to restore the state after the recovery. And same with deployment. As you're deploying, right, a new code is going to get started. So that new code, if you want to still use the old state, you're going to need to put stuff into storage. So storage is incredibly important if you want to survive a restart. So let's look at the API. It's a server-based concept, right? So the API is basically, it's storage against a room. So you'd be able to say room storage get. That allows you to get a specific key. You can put a value using key and value, and you can delete a value, or if you want, you can list. But obviously be careful, because if you have tons of keys, your list could be a very expensive operation. Now, typically, this is where you would write on the server inside an on connect, on close, or on message. For example, like somebody connects, you might want to write some initial state into your storage. Like this person, I don't know, this is the value the initial value for them. Or if they close, sometimes you need to remove state to say like, oh no, they're gone. So let's update the state to say they're gone. And of course, on message, messages are coming in. It's obviously going to mutate the state somehow. Usually, that's a very common pattern. Now, there's also an on start, and this is where the restoring happens. So anytime the server wakes up, like we said before, from a reboot, from all those other conditions, it's going to call the on start, and here you would typically recover state from storage. But be careful, I would say, because you don't want to load up a ton of data. It's going to slow down your server. You're also limited to 128 megs of RAM, so you shouldn't just like load the whole world into memory, right? Okay, so now I'll show you guys a demo. And our demo is going to be basically a mouse cursor. Okay, so our demo is basically that we are sharing cursors here. You see on the top corner, when I move my cursor, you see it moving in the other window. Same for all the other ones. So basically, every single one of these windows is a socket to a server, and that server is keeping track of the X and Y position for each connection. Okay, I'm going to show you that code. It's actually remarkably quite simple. So here I am in the mouse pointer server file. And what you see is that when people connect, right, we start them off with a point of x0, y0, and we shove that into storage here by calling put. Now, as the key here, we're using the connection ID. Now, you don't have to do that, but in this case, because we're storing against each user, it makes a lot of sense to do that. So we just store the point. Once that's done, we broadcast. So this is just a function that I wrote, because you would normally do this.room.broadcast, but I extracted it to its own function just because it's easier that way. So if we go down here, you'll see the extraction function. All it does is it gets all the keys from storage. And again, remember, this might not be efficient. I'm just showing you a working solution. In the future, we can look at how to make it more efficient. And what we do is we then serialize the points with JSON, and we broadcast it to everybody inside the room. So the effect is that when somebody connects, we let everybody know, hey, this guy connected, and he's at 0, 0, x0, y0. Then when a message comes in, so the message format is always going to be x, and y. Like it's always going to be a point. That's as JSON. So that's basically the payload that's coming in here. We pull it out, and then for TypeScript as a point. And then what we do is we basically update the storage. So we say, okay, this sender ID, let's say it's me, Josh. So let's say the sender ID was Josh. Basically, the key is Josh, and the value is the point. And then again, we broadcast to everybody, hey, the point changed for Josh. So we need to let everybody know. And then on close, this is where we want to clean up, right? So what we're going to do is we're going to delete, in this case, from storage, and then we're going to broadcast everybody to let them know that user is no longer part of. So essentially, we're broadcasting an object that the keys are the sender IDs and the values are the X and Y position. So as you can see, it's quite easy to do. All right, guys, see you in the next one.